Today we got an old Hitachi CMP420 version 2. This is a plasma screen from 2004. This one's dead. Now this is a rework of a video that was done, I think probably 7 or 8 years ago. And we're going to shorten this one down, get right to the point, and show you what went wrong with this one. If you got one of these ones here, more than likely if it's dead, this is the fault. Check it out. In the back, we'll see this set's populated with tons of boards. This being an older model, we have Y sustain board, and if you look at these big ICs here, this looks to have the hybrid ICs. This is going to be an LG made unit. Here's our power supply board, our Z sustain, our common mode sustain board here. Again, it's got the hybrid ICs. We have our control boards down here and our interface boards. This set does not have this is actually, I guess, our AV interface here. This set does not have a tuner in it. It is just a monitor. What's kind of cool about this unit is if we take a look at the bottom, it's got your normal AV inputs on it. It also has a SCART input, which is kind of unique. That was more used in Europe than anything else. And over on this other side, a DVI input, as well as VGA inputs, and this is an RS-232. It's obviously probably for updating the software. But this one's totally dead. Okay, on this plasma, this is our power supply board here, and because nothing's working at all, I have to assume that we may have a problem in the standby supply. So, standby, I believe, is this little transformer here. So let's just hook up the meter and we'll measure some voltages and see whether there's anything. I got nothing here on the secondary side. Just measuring around some of these components, and there's nothing on the secondary side here. This will be the primary, so I got to find a hot ground, and we'll check and see if there's anything going on the primary side. My oscillator's not working, but as you can see here, when I measure across the capacitor here, there's still 34 volts charged on this thing. It's slowly discharging. This is the primary filter here on the standby supply, which is what I thought this was, the standby supply, and it is. As you can see, it's slowly discharging. This oscillator is not running for the standby supply. If the standby supply doesn't start up, then we have no chance of the set starting up. Okay, how these sets normally operate is this is the standby supply here. This is the primary filter. Our raw B plus is filtered here for our standby supply, and the oscillator will be on this little module here. This will be the oscillator that controls the 5-volt supply. And typically how they work is when you first plug them in, and they need a kickstart to get them going. It's usually a small capacitor somewhere in this circuit. I'm thinking probably that one right there. This provides a pulse to start the oscillator going, and once the oscillator starts going, then it continues to run. So let's check the ESR on this capacitor, and that would put it, this one right there, and I'm measuring 4.7 ohms, and that looks to be a little bit high. So I've got the cap in my hand here. As you can see, it's coming up at 2.4. We're going to replace this capacitor with a new one, and we'll try the set and see whether the set will start up. But I have a feeling that that might be the problem on this thing. Okay, so I've got one new capacitor. That's all I've changed on this, is that one little small, it's a boot type capacitor, a soft start. Sometimes people will call it the bootstrap capacitor. It's not really an accurate name for it. An accurate name would be a soft start or kick capacitor, kicker. What its job does is, as it charges up, it just provides enough of a kick to get it going. Quite a common design on some of the old RCA TVs going back into like the early 80s. They would use a start capacitor that would start the set, start the oscillator running, and then once the oscillator got running, there was a feedback from the secondary would keep the oscillator running. Anyway, a little different design on these, but same concept. Let's put the board back into the TV and see if the TV will turn on. So now I have to connect all these plugs up again here for the sustain boards. And as you can see, these old plasma sets had a lot of stuff in them. Okay, let's see if this thing's going to work. I'm just going to plug the power in. Okay, you guys can see the meter there. I'm going to test it to the test point up top here. This is the filter capacitor. If you can see the meter at the bottom of the screen, we have 5 volts. So the standby power supply is running. Let's try turning on the set and see whether we get any action from any of the lights on here. So I hit the power button. Okay, I heard a click. Okay, got some lights happening down here. I don't know if you guys can see them, but there's some green lights happening on the set. Let's see whether the panel's lighting up. Well, I have a solid white screen, which is better than I had before. I had nothing before. So, we are definitely making progress. Plug in the color bars from the camera and we have a picture. This one's fixed. I'm just going to put the back on this set here and see how good the picture on this thing is, because this set looks like it could have a really nice picture. It's not a high definition set. If you look at this, if I get the camera in close, you can actually see the individual cells. Okay, there's the individual cells on the screen. I'm going to go over to the yellow. You'll see these are individual little light bulbs. See if I can focus this camera better. It's probably the best I can get the focus there. But as you can see, this is how color picture is made up on a plasma. You've got these individual little cells. And there's blue. Anyway, I'm going to get the back on this thing, and actually, I'm going to plug a video source into it first. I'll plug a component source in and just see how it looks. Okay, we're going to look at the picture quality off this set. Remember, this is standard definition. We're going to compare it to the 1080 set over here. Now, this one on the left is a 1080 television, 1080p, and this one on the right is a 480p. But it's not bad, you know. It doesn't have the detail for sure. And I'm sure you can clearly see the screen on the left has more detail. But for a 480 television, it's actually not too bad. Oh yes, yeah, it's cranked way up. Let's just put everything back down to 0 and see how things look. That looks a little better. Put contrast in normal. I'm just going to turn the, it's got day and night mode. Oh, okay. So that's the difference it makes. That looks better. That looks better. I think it changes the color temperature too. That looks a bit better. There, now I've made some changes to the settings, and yeah, that actually looks very good. Thanks for watching. We'll catch you in the next one.